You may look at the title of this video and say, oh no, I just learned about the derivative and we already have some new second kind of derivative. Fortunately, no. The second derivative just means take the derivative of a function, then take the derivative of your answer, and then you've taken a second derivative. So there's a notation for that. So let me show you a second derivative. So if f of x is, let's say 2x to the fourth. So I have f of x is 2x to the fourth, then f prime of x, I bring the 4 down as a multiplicative factor, so I get 8x cubed. And now, if I wanted to keep going, I could take yet another derivative, and I would like to have a notation for that. So what I do is just put another prime on there. So it's essentially two apostrophes next to each other. It's not an 11, and it's not a geometry parallel sign. It's just f double prime is what it's called in Newton's notation. And so we would get 24x squared. So this thing right here is called the second derivative of f of x. You've taken the derivative once, and then you've taken it again. We could express these same ideas in Leibniz notation. So again, we would have f of x equals 2x to the fourth, df dx equals 8x cubed. And now we want to show sort of another round of df dx. And you do it with little exponents. It's d squared f dx squared. And you can get into a whole interesting conversation about, wait, are those really squareds? And the answer is no. As you can tell, I'm not exactly emphatic about it. But the language here is just, you put a 2 here and you put a 2 here, and that means second derivative. If you put a 3 here and a 3 here, that would mean the third derivative. And if you put a 19 here and a 19 here, that would be the 19th derivative. Not that that's useful in physics. Pretty much we end up just taking either first or second derivatives of almost everything in physics. So this slide and the previous slide show the way to express a second derivative.